Hi everyone. In this video, I want to talk about unions, intersections, and complements. Okay, so let's just start with the idea of sample space. We've already talked about the sample space for a particular event. We talked about a couple trying to have 3 children, and we listed the sample space, which is all of the ways that, that could happen. And so if we try to visualize this, represent it visually, what we're going to end up with is we have this space. And in this space, anything within the realm of what we're talking about is possible. So let's just say that this sample space is a die toss, okay? So this is all the ways that we can roll a dice and the outcomes that can occur. So we know that that exists. If there are points somewhere on this 1, 2, 3, 4, 5, 6, and let's say this is 1, 2, 3, 4, 5, 6, okay? Those are all the events, and I just put them wherever felt right in the moment. And so if we had an event, let's say we have event A, and event A says we're gonna toss the die and end up with an even number, then that event is gonna occur here. Okay, we want that to encompass those 3 points. Okay, so this is event A. And then we have event B. And event B is that we toss the die and we get a number less than or equal to 3. And so this is event B. Okay, notice that 5 is an event that, or is a value in this sample space that just isn't something that I care about. It's not one of the favorable outcomes that I'm looking for. So we have event A, which is tossing an even number, and we have event B, which is tossing a number that's less than or equal to 3. So we can see 2 things here. So this will help us talk about unions. So if I wanted to know what A union B is, that would be everything that encompasses what A does. So that's, I'll do it in green. That's all of this area here. And then all of the points that B encompasses as well. So A union B says find everything in both of these sets. Okay. So A union B would consist of, the elements 1, 2, 3, 4, and 6. Okay. So there are 5 favorable outcomes there for A union B. If I were to find the probability of A union B, that would be there's 5 different outcomes and there's 6 possibilities. So the probability that I either toss an even number or I roll a number that's less than or equal to 3, there are 5 values that encompass that out of the 6 total. And what you notice is I use the word or. A union sign is an or. So in math, or means that this happens, so event A happens, event B happens, or they both happen. That's an or. So now let's talk about what does it mean when I say and in math. If I want to know the probability of A and B, Well, first I need to know, well, how many data points are both in A and B simultaneously? And that's this area right over here. And right now it looks like there's only one value there. This consists of the data point 2. So the probability of A and B, meaning both are true at the same time, or means that one is true, the other one is true, or they're both true. And means both of them are true at the same time. So the probability of A and B would be, there's only one value there out of the 6. So the probability that we're going to toss an even number that is also less than or equal to 3, well, there's only one even number on a die that is less than or equal to 3, and that number is 2. So there's only one of them out of the 6 total possibilities that could happen in this sample space. Okay? Now, there is other stuff happening here. Notice how we still have this one value outside. This space here, so A union B is all of the space, and I'm going to outline it here in red with a thicker marker. So this is, and forgive me while I try to trace this. Okay, so all of the stuff in here, this is A union B. All of the stuff that I just shaded in is A union B. A union B complement is everything that's out here. Now, the way that I drew this, there's only one value that's out here, and that is that's the value 5. Okay, that's the value 5 that rolls, that if we rolled a die, if a 5 came up. And so it turns out that the complement of A union B would be 1 out of 6. Notice when I add the original and the complement together, I'm going to get 6 out of 6, which is 1. Anytime I add an event, the probability of an event happening with its complement, with the complement of that event, I'm going to end up with 1 as an answer. And we've already talked about this briefly in a previous video, but we're going to talk about this in a little bit more detail. When would we want to use this idea of a complementary event? So the complement of an event A is the event that A does not occur.